These notes are going to start on page 10 in our Unit 2 packet. So we're going to go over a few examples of calculating density mathematically. First, notice that there's a chart here with various substances with the density in grams per milliliter, specifically at 20 degrees. In our notes, it did mention that temperature can affect the density of a substance. So it's important to kind of make a note of what temperature that density is at, because as things warm, they can expand a little, changing their density, or oppositely, as they cool, they can kind of contract a little, again, changing their density. This table will be needed for the problem. Sometimes the problems will just reference the material and only give you one other variable. So if it says you have a certain amount of gold, you need to look up the density of gold and fill that in to your work. So one other thing, obviously noted here, that table is in grams per milliliters, but based on our cube graphing lab activity, we should know that 1 milliliter is the exact same as 1 centimeter cubed, so you can just swap them out interchangeably. All right, for any of our problems here, I'm going to want us to write a little variable list on the side, D, M, and V. As we're looking at our problem, then we're going to read through. So a sample of metal has a volume of 45 centimeters cubed and 125 grams. What is the density of the metal? And then the identity. So we'll go through and fill in centimeters cubed. We should know is volume. So I'm going to plug that in here. And we should know grams is mass. So I'll plug that in for my M. And I will be requiring you to show me work along these lines. For the second amount of work, you can either, and you can do both of these if you would like, write the arranged equation and plug in your numbers. So if you just want to have your numbers plugged in equal to D for density here, you can do that. We will want to care about sig figs here. So looking at our two numbers, we see that the volume is 2 sig figs and the mass is 4. So our answer should be recorded to 2 sig figs, which ends up being 2.7 grams per milliliter, or rather centimeter cubed, I guess, in this case. Again, they're interchangeable, but we'll try to stick with the units that the problem gave us. Okay, so ideally you give me all 4 of these, but at the very least, I need this amount of work, D equal to what you're kind of plugging in your calculator, and then the answer. Okay, going on to the next one. Oh, we have to identify them all. My bad. So looking up 2.7, if we can see here, is aluminum. Okay, next problem. We have the mass, and it tells us it's gold. So again, this is where it only gives us one number, but the inference here is that we can figure out it's gold. Based on the chart, we would know the density. Volume, 25 centimeter cubed. Looking and knowing your units is the easiest way to figure out where each number should go. So if you see centimeter cubed or milliliter, that's a volume, grams, mass, and then a derived unit of G/ml or cm cubed is density. Looking at our table here, we have gold is 19.300. And that is going to be grams per milliliter in the table, but because this is centimeter cubed, I'm just going to swap it out for centimeter cubed. And I'm solving for mass. So in this case, you can write the arranged equation for mass. So if you rearrange this equation for mass, it would be M equals D times V, which is in our notes. And then you can plug this in with your numbers. So 19.3 times 25. One thing I do want to mention is notice how I was lazier in writing my sig figs here. I didn't put the extra zeros or the 0.0 here. You want to make sure that when you go to round it, you're looking at the original numbers and not the work, because a lot of times people do what I did and just write 25 instead of 25.0. And then when they round, they use this number instead of the original one that had the 3 sig figs. So this one, because of this number, should be 3 sig figs for our answer. Multiplying across, we get 483 grams. Okay, and then I'll do one more down here for volume. So again, DMV. Again, a gold nugget here. This is just bonus information, and then we get a mass. So we're looking at the volume. So density, we know, is still 19.3 from the table, and grams is the other thing we have, 93,300. And then we're solving for volume. In our notes, again, I've rearranged this equation, but I do want to just be very clear on how to solve this if you're trying to just remember the density equation as D equals MV. When you solve for volume, oftentimes students will just take M and divide it, so it's D over M, but that is not the correct algebraic rearrangement of this formula. Because if you move M over, you're left with 1 over V, not just V. So you would need to flip that fraction or get an answer and then take 1 over that answer. Oftentimes I say that this is probably the better equation if you're going to memorize a version of it, which is the slope version of it, because it's just easier to do the algebra. It's easier to see here that when you're solving for the volume that you're going to end up with mass over density. And that's less obvious in the original density equation, just based on what I've seen in the past. All right, lastly, we'll plug it in. 19, not 19 on top. We're going to do 93,300 grams divided by 19.3. This has 3 sig figs. The density had more, but we'll go with the lowest. And so we get 4,830 centimeters cubed here. Again, try to keep consistent with either what the problem's asking. If it didn't specifically say centimeters cubed, then we could put milliliters here, since that's what the table told us the units of density were. That's essentially one type of each thing you'll have to solve for. There are some that are a little more complicated, so I'm just going to scroll to one of those just to kind of indicate what you would have to do here. And that is, so like in, for example, number 10, you're not given volume. You need to first determine volume based on the measurements given. For number 12, you see this is in kilograms. Make sure you're paying attention to units. The table is in grams per milliliter. So if you don't have grams or milligrams, you need to show dimensional analysis converting to the correct unit before you plug it into the equation. In number 13, we see we are talking about water displacement. So remember from the past that water displacement is the difference between these two volumes. So the volume of your object is going to be the difference between the height in water and the height of the water originally. So just a few extra things like that that you want to make sure you're really reading carefully when you're trying to solve. Other than that, you're just working through pages 10, 11, and 12 and trying to have those questions done.